Communities. Different types of species making up the populations together. Okay, just what sort of togetherness is this? We do see similar looking communities in different parts of the world. The exact types of things in them is somewhat different, but broadly similar communities. For example, open grassland areas, we tend to see some large grazing mammals, common ones that can move fairly fast to escape predators. Whether this would be, say, the bison of the American plains or the antelope in Africa, along with even bigger things like elephants and rhinos and whatnot, or even the kangaroos in Australia. So we see some similar patterns there. But to what extent do these communities kind of hold together? Or is it just that here's a bunch of species that all happen to like more or less similar things, and they all overlap in this place, but they're not particularly attached to each other if there's change? Turns out when you look closely, our communities tend to kind of fragment. It's not all these species are always together, but rather that each one has its particular own preference. Now many of those are broadly overlapping, and so you do tend to find certain things together, but each has its own particular specialization. This is an example looking at major tree species in forests in Wisconsin, and going from very wet areas to very dry areas. By Wisconsin standards, they don't have deserts there, but there are drier and wetter places. And with that, we see different amounts of the commonest tree types that like different conditions. This is not one total community that are always together everywhere. Each one of these plants is responding to its own set of needs in the environment and varying in the details of its abundance. This is shown up very vividly when we look not just at the present, but go back into the past for evidence of change. Plants with their pollen, relatively durable, preserved as well as fossils, and different types of pollen are often quite different and easy to recognize. And so we can get a pretty good idea of what types of plants were where as we go back in time. And geologically, we don't have to go back far in time before we hit the ice ages. And we're going back and forth from glaciers extending down all the way to northern Pennsylvania, much colder conditions across North America, versus glaciers retreated back to Greenland, even to slightly warmer than today at the warmest peaks of the ice ages. Okay, when we look at the pollen, we see that each plant has its own preferences and is changing differently from others. So when we go back to Ice Age, we see mixes of plants that we do not find today. Under those different conditions, each one, of course, one plant can't get up and run away because the glacier's coming, but if the glaciers is coming, then we're going to see more of the seeds grow to the south, fewer to the north, because it's getting too cold to the north. And so over time, we'll see plants growing further south as the glaciers are advancing, further north as they retreat back. But different ones make those changes differently, and so we get mixes totally different from anything we see today as we look back at the pollen patterns back in time. So communities in general are relatively loose associations, organisms that have similar environmental preferences, and so will be living in the same environment. You do have some examples of species that depend on particular other ones, and obviously those are going to be more closely associated. And if something changes, they may be vulnerable. For example, there's a group of fungi known as rusts. And these grow on different types of plants in different stages of their life cycle. These pictures here are what's sometimes referred to as a cedar apple. These fungi grow on junipers and similar conifers. And then the spores from this life stage will then grow on a very different plant. For example, sometimes some of these affect apples, and so are not popular with apple growers. And then back and forth, so this fungus can only live where there's juniper and apple trees reasonably close to each other. Similar thing, migrating birds. Typically, they are migrating for the summer to some place where they can get lots of nice, yummy, protein-rich bugs to feed the babies that they are raising. And so they need to have the right timing to get a big crop of insects, which typically follows the spring growth of the plants. But if we have change, like from global warming, timing of the plants and insects may change. Are the migrating birds able to adjust? They're depending on the relationship there. If there's a disturbance, again, we'll go through the pattern of succession, pioneer to mature communities over time.